Let's talk about the application of concrete. After the mixer discharges the viscous matrix, it may go onto chutes to guide it directly to the concrete site. If the truck cannot get close enough to the site to use the chutes, the concrete may be discharged into a concrete pump, connected to a flexible hose or onto a conveyor belt which can be extended some distance. A pump provides the means to move the material to precise locations, multi-floor buildings, and other distance prohibitive locations. Because concrete is usually prepared as a viscous fluid, it needs to be poured into forms, which are containers erected in the site to give the concrete its desired shape until it sets. Forms can be temporary or permanent, and they can be built on site out of timber, plywood, moisture-resistant particle board, steel, aluminum, plastic, etc. False work consists of temporary structures used in construction to support spanning or arched structures in order to hold the components in place until its construction is sufficiently advanced to support itself. When concrete matrix is poured into a form, from 10 to 30% of the concrete is irregularly distributed, depending on the mix, size, and shape of the form, and amount of reinforcing steel. A vibrator causes a violent agitation of the particles in the mix and makes them flow under this effect tightly against the form and around the reinforcement. Mostly vibrator is immersed in the matrix and waves carry outwards in the surface. When initially mixed, cement and water rapidly form a gel of tangled chains of interlocking crystals, and ingredients of the gel continue to react over time. At first, the gel is fluid, which improves workability and aids in placement, but as concrete sets, the chain of crystals join into a rigid structure, counteracting the fluidity of the gel and fixing the particles of aggregate in place. Workability is the ability of fresh concrete mix to fill the form properly without reducing the concrete's quality. Workability depends on water content, aggregate shape and size distribution, cementitious content, age, level of hydration, and presence and type of admixtures. Workability can be measured by the concrete slump test, a simple measure of the plasticity of a fresh batch of concrete. Slump is normally measured by filling an Abrams cone with a sample from a fresh batch. It is then filled in 3 layers of equal volume, with each layer being tempered with a steel rod to consolidate the layer. Then the cone is lifted off, the enclosed material slumps a certain amount. A relatively dry sample slumps very little, having a slump value of 25-50 mm out of 300 mm. A relatively wet concrete may slump as much as 200 mm. This first figure shows the true slump. If the slump is like this, it's potentially non-plastic. It's really rigid. It already set. It has already set. A collapsed slump is potentially non-cohesive. Shear slump means it's not mixed well. A common misconception is that concrete dries as it sets, but the opposite is true. Damp concrete sets better than dry concrete. Cement needs water to become strong. Too much water is counterproductive, but too little water is deleterious.